In previous lecture, we had discussed the first come first serve scheduling algorithm. We have also seen how to prepare a Gantt chart, and also we have calculated the waiting time of the individual process and average waiting time of all the process. So this is the extended lecture of first come first serve scheduling. So we will be having one more example on first come first serve scheduling. But before that, we will understand the Conway effect. So this Conway effect is nothing but there is a Conway effect as all other processes wait for one big process. Now what we are saying that all other process wait for one big process to get off the CPU, means one big process is in the CPU, right? So which is executing, all other are waiting, because one big process is in the CPU. So until it get terminated, so all other are waiting. So such kind of scenario is called as Conway effect. So this effect result in lower CPU and device utilization. That might be possible if shorter processes were allowed to go first. This Conway effect will not rises. Now coming to the example, we have example, there is a table consisting of 5 process. So we have 5 process and their arrival times are different. In previous lecture we had 3 processes, and all the 3 processes, their burst time is mentioned, but we have not mentioned their arrival time. And we said that consider the all the set of process arrive at a 0 millisecond, means at a time they arrive, and whichever comes first get first CPU. Now here their arrival time is different. Now P1 arrived, arrival time is 4 and its burst time is 5. P2 arrived at 6 millisecond, burst time is 4. P3 arrival time is 0, burst time is 3, and P4 arrival time is 6 and burst time is 2, and P5 arrival time is 5 and burst time is 4. Now based on this we need to prepare a Gantt chart. So we have prepared a Gantt chart. In this Gantt chart, if you see, a P3 process means the arrival time, we have to see the arrival time. So arrival time of the P3 is 0. So at the 0 time the P3 is arriving and its burst time is 3. So it is executed 3 millisecond, and thereafter if you see the arrival time after the 0 arrival time, the next arrival time, the shortest arrival time is 4, that is 4 millisecond. So next P1 process is occupying the CPU. So between this P3 and P1, right, the shaded box which represent the idle time of the CPU, means CPU sat idle during this period. So none of the process is occupying the CPU, so CPU is totally idle. Now thereafter the next arrival time means the next arrival time is 5, the P5 is arriving, right, and next P2 and P4, they are arriving at the same time, but whoever comes first will occupy first. So the P5 is the next process, P2 is the next, and P4 is the next. So based on their arrival time, right, we have arranged this sequence. And also, so burst time is also mentioned. So all the processes will get the CPU for their burst time. So once they complete their execution, the CPU allocate to the next process. In this way, if we want to calculate the turnaround time, for calculating the turnaround time, the formula is completion time minus arrival time. So the completion time of the process minus arrival time, and waiting time of the process is calculated based on turnaround time minus burst time. So how to calculate it? So through this table you can understand, if P1 process is there, the completion time is 9. So why we are saying 9? Because you can see this is the completion time of P1 process. Okay, P2 process is completing its process in 17 millisecond, and P3 is completing its execution in 3 millisecond, because burst time is 3 and arrival time is 0. Now P4 is 19, you can see 19 as per the Gantt chart. So first we have to prepare the Gantt chart so that it is easy to calculate all other things like completion time, turnaround time and waiting time. P5 completion time is 13, right? It is completing its execution here, that is the 13 millisecond. Now how to calculate the turnaround time? As the formula says that completion time minus arrival time. So completion time of P1, so already we have this value, right? Completion time, so we take completion time as 9 minus arrival time. So what is the arrival time? So this is the arrival time, 4. So 9 minus 4, 5. 5 is the turnaround time of P1. So waiting time, how to calculate the turnaround time? So the turnaround time is 5, right? And waiting time is the burst time, sorry, turnaround time minus burst time. So this is the 5 is the turnaround time, burst time is also 5. 5 minus 5, waiting time is 0. Because see how this will become a 0, right? So P1 arriving at 4 millisecond, so arrival time is 4. So at the time the P1 arrives, the CPU set idle, means for P1 directly occupies the CPU, so it is not waiting. So 0 second is the waiting time, right? So hence the waiting time of the P1 is 0. Let me go to P2, right? So already we have calculated completion time, that is 17, right? So for calculating turnaround time, 17 minus 6, that is arrival time. So we have to go for this table, arrival time, right? This is the completion time, 17 minus 6, 11. So 11 is the turnaround time of P2, right? Turnaround time of P2. So waiting time for P2 is 11 minus 4. 11 is the turnaround time. This is the turnaround time. Just only we have calculated. So minus 4. 4 is the burst time. So we have to take the value from here, burst time, right? 11 minus 7. 11 minus 4 is equals to 7. 7 is the waiting time of P2 process. Similarly, we can calculate P3 also. So completion time is 3. So completion minus arrival time. So arrival is 0, right? 3 minus 0 is equals to 3. So total turnaround time is 3. Now turnaround time minus burst time, 3 minus 3 is equals to 0. 0 is the waiting time. So P3 is also waiting for 0 seconds. So P3 is the first process which entering the CPU. So CPU, this waiting period for P3 is also 0, right? So both P1 is 0, P3 is 0. Now coming to P4. So completion time is calculated, that is 19, right? 19 minus arrival time. So arrival time we have to take from this first table, that is 6. So 19 minus 6, 13. 13 is the turnaround time. And next, turnaround time minus burst time is the waiting time. So turnaround time is just only calculated, that is 13. 13 minus 2. 2 is the burst time. So we have to take 2 value from here. So 11 is the waiting time. Similarly for P5, completion is 13 millisecond. So that is completion minus arrival time. So we have to take the arrival time from first table, that is 5. So 13 minus 5 is 8. So 8 is the turnaround time of P5. Similarly, there is a turnaround minus burst time for waiting time. So 8 minus burst time is from first table, that is 4. So 8 minus 4, 4. So 4 is the waiting time for P5 process. So this is how we can solve this problem. So in most of the competitive exams, such kind of table you are getting with the different arrival times of the processes and burst time. So you have to prepare a Gantt chart to solve a particular question. So they might ask you the turnaround time of a particular process or waiting time of a particular process. So until you prepare the Gantt chart and this table, so you can't get the answer. So in most of the competitive exam like NET, SET, GATE exams, these kinds of questions is frequently asked. Okay. Now this is the table what we are having, right? So turnaround time and waiting time of each of the process. So now we have to calculate the average turnaround time. So average turnaround time means we have to add all the uh, turnaround times, that is P1's 5, 11, 3, 13 and 8. So we have just only calculated all these values. So these are the turnaround time of the process P1, P2, P3, P4 and P5. So we are saying that the average turnaround time, average means all the 5 processes average we have to calculate. So for that we have to add the turnaround time, that is divided by number of process 5. So we are getting 40 divided by 5, that is 8 milliseconds. So this is the average turnaround time. And similarly we can calculate average waiting time. So for calculating average waiting time we have to add 0 plus 7 plus 0 plus 11 plus 4, and that is divided by 5. So it will become 40. I hope it is wrong. 7 plus 11 18 plus 4 22. So 22 is divided by 5. This is 22, not 40. So 22 divided by 5, 4.4 millisecond is the average waiting time, right? So average waiting time. So this is how we can calculate if the process arrives in different time. All processes are not arriving at a same time. So if process arrives in a different time, so we have to prepare such kind of Gantt chart so that we can calculate its waiting time, completion time, turnaround time, and also we can able to calculate the average turnaround time of all the processes and average waiting time of all the processes. So hope you understood this example. So let's see you in the next lecture with new example. Thank you for watching.